Hello, today we're going to start by looking at our practice check, but then we're going to get a chance to focus on strategies that students had when approaching one of our big problems from today. So looking at this, it's helpful to find either a way of scaling or of using a constant of proportionality to get the missing information in this table. So if we know that 5 minutes is going to fill a tank 8 gallons, 5 times something is 8, but it's not clear what. It's not a whole number that you can multiply 5 by. So I'd like to scale down the table. I'm going to look at how I can get from 5 to 1 on the time side. Well, 5 divided by 5 is 1. So on the other side, 8 gallons, we would also need to divide by 5 so that we're scaling down by 5. And that would give us 8 fifths, which is the same as 1.6 the decimal. So now if I look across the table, getting from 1 minute to 8 fifths gallons, I could multiply that by 8 fifths. That gives me a constant of proportionality of 8 fifths. Doing the same then, below, I can do 3 times 8 fifths, and that gives me 48. And if I were to go back across the table in the other direction, 40 divided by 8 fifths, or 1.6, is 25. And then I could check that by saying, well, if I did 25 minutes times 8 fifths, I would end up with 40. So the constant of proportionality here, going from time to water, is 8 fifths. We would say that the amount of time it takes to fill, the amount of time that you've been filling the tank is proportional to the amount of water that you've used, and the constant of proportionality is 8 fifths. That is to say that for every minute that the tank is filling, it will fill 8 fifths of a gallon of water, or 1.6 gallons of water. So we can use this for much larger numbers then. You could do 40,000, working back across the table, divided by 1.6 would give us 25,000. And you might also notice that this is scalable easily from that bottom row of the table as well. 25 or 40 gallons, you could scale up by 1,000 to get 40,000 gallons, and that means you need to scale up the 25 minutes by 1,000, and so it would take 25,000 minutes. Now we could figure out how many hours that is, because 25,000 minutes is a lot to consider, so you could do some work there to figure out how much time that would be, how the conversion. But then I want to move on to your strategies that you used here. So we've got a recipe for 4 pancakes, and we know that 4 pancakes take 6 tablespoons of flour. I want to know how much flour you would need to make 10 pancakes. I've got 3 strategies I'd like to show you. The first, we're going to call this the Rodney James. In the Rodney James strategy, Rodney reduced the ratio of 4 to 6, which was that 4 pancakes compared to 6 tablespoons of water, all the way down. He said that would be like saying 2 pancakes would take 3 tablespoons of water. Then he asked himself, if we look at step 2, what could get me to 10? Because he needs 10 pancakes. He noticed that you could multiply by the numerator and denominator by 5. You could scale up by 5, and you would end up with 10 pancakes needing 15 tablespoons. So that's a really nice example of using scaling. Now we have the Nikayla and China method, which is also an example of scaling. And I apologize, I talked about this as a constant of proportionality in class. It is not. If you look at it, you see that they wanted to scale their recipe up from 4 pancakes up to 10 pancakes. And where Rodney went down to 2 pancakes and then up to 5, so he divided by 2 and then multiplied by 5, they realized that they could divide 10 by 4 to get that there is a scale factor of 2.5 that they can use. And so they went straight to that scale factor, and then they were able to scale all of the other parts of the recipe. So we see that 6 tablespoons is going to require 15 tablespoons, and they were able to scale up all other parts of the recipe as well. So here's a scale factor where they did everything in one step, rather than scaling down and up like Rodney did. And then last, we have a combination of scale factors and a constant of proportionality being used. And looking at this, as you go down the table, you see the scale factor. This is like Nikayla and China's scale factor times 2.5. But looking across this table, you can see that David, Keon, and Aaliyah did something a little bit different than Rodney and Nikayla and China did. They looked at the relationship between pancakes and flour, or pancakes and milk, in the bottom of the table. And they said, how can we get across? Well, with the pancakes to flour, they were able to see that they found that 4 times 1.5 would get you to 6. So if you took pancakes, that number, you kept it, and then you added another half, so times 1.5, you now would be at 6 tablespoons. That constant proportionality should continue to hold because this is a proportional relationship. So if we go down to 10 pancakes, you can multiply that by the constant of proportionality, 1.5, and you have 15 tablespoons that would be required. So 3 different ways of showing how you could get to 15 tablespoons. This is convincing. Once you have 3 ways that use different strategies, use different ways of visualizing it. You notice that Rodney didn't use a table. He was really focusing on the ratios. These 2 have focused more on the use of a table, but they use them in different ways. So I would suggest going through the 3 again and looking at how those strategies were different and what connections there were between them, because all of them together provide a very convincing argument that 15 tablespoons definitely seems like it's going to hold for that ratio. As you were looking at the homework tonight, this is a callback from Thursday where people were thinking about fractional parts of hours. If you know that 20 minutes is some amount of the hour, consider how much is 20 out of the 60 minutes, and how could you express that fraction? We have 20 over 60. That is already a fraction. When you can express out of using a fraction bar, you have a fraction, but you can reduce that fraction as well. And I'd really be interested in seeing how people can use double number lines, how people can use fraction bars, or even a circle to represent a clock, and the fractional parts of that. That would be interesting to see. As we moved forward, in the homework, I want to see you using some of the strategies that we saw in class today and that you also got a chance to see on the video today. So if you are trying to look at a proportional relationship and you just have some information provided here, I suggest that you try making a table and then use some of the strategies that you saw in this video. As always, reach out if you have any questions, but before you say, I'm not sure what to do, think about the information you have and think about the structures that you can use to organize that information. I've had people this week multiple times say, oh, once I see I can put this in a table, it suddenly makes so much more sense to me. So tables, double number lines, diagrams, those are there so you can make sense of the numbers. At no point should you feel like you just need to combine numbers in some way just because they're in front of you. You definitely have the strategies to be able to see how are these numbers related to each other, how are these quantities organized.